Okay, let's see if we can get a little recording going. So we're looking at a few problems from section 3D.1. That's like look like a B. It's supposed to be 3D.1. 3D.1, and let's start with number 2B because problem number 1 are kind of like the simpler versions of number 2. Because problem number 1, those are all just doing distributing. So what we're doing is we're working a lot with power, so really testing our ability to apply the power rules. So let's just take our time. I'm going to go ahead and write this first one. It says 3 to the x power. And a question that Sarah had was, I think basically she's getting the overall patterns. And if you notice at the top of the lesson, they're giving us 5 general patterns. They're saying, hey, don't look at like the very first pattern. I'll write it just in case you don't know what I'm talking about. It's in that little blue box. If you don't have your book open, you should open it while you watch me. So that's that first pattern, right? That's the distributive property. And I didn't have room to write it. But what they're telling us is like, hey, even though you got weird things like 3 to the x power, you could think of that as just a. So like this problem, you could really think of it as a plus b times, it's really a over again, plus c. And if you look up there, there's not exactly that pattern. There's a pattern very close to it, which is a plus b times b. No, c plus d. My bad. So like if all of the letters are the different. So, and then in this case, of course, the a and the c are really the same thing. But then it just tells you what that's going to equal. So you could kind of look at it first in a very generic sense and then put the exponents in. But for the most part, I think you've done enough of these, what do you call these, foils, that we can just kind of do. We'll just take our time with it, and then we'll write it all out. Don't try to shortcut it in your head. Just write it out so that you can see where you can break things down. Because the tricky part, like Sarah's asking, is, well, how do you know how to simplify it? Like how far? What's more simple than the other thing? What's one thing's more simple than the other? Well, why? So let's look at that a little bit. So let's start with the first terms, 3x and 3x. So that's 3x. I'm going to write everything in parentheses. And then we're going to do that's the first term. Now I'm going to do the outside term. So that's going to be plus 3x times 5. And then I'm going to do the inside term. So that's going to be 2 times 3x. And then I'm going to do the last terms, which is simply going to be 2 times 5. That one I'm going to do in my head. 10. That one's pretty straightforward, right? 2 times 5 is 10. So now we got our 4 terms. Now we have to simplify it. So I don't know. I haven't done enough of these to know if there's always a pattern. I'm guessing like if this term and this term are the same, yeah, there'd always be a pattern in the middle that you could do a little, you could extract out, or what's that word? Factor. The word's factor. God, my mind's already losing these words. So you could factor out a 3 to the x power. See that? Because I have one here and one here. So I'm going to factor that out, and I'm going to have 5 plus 2. Because I can take the 3x out of the 5, and I can take it out of the 3x out of the 2. That's tricky. You might not see that at first. If you're looking at the answer, and you're like, well, how the heck did they get 7 times 3 to the x? There it is. 5 plus 2 is 7. And then I just rearranged it. There's the plus 10. Now, let's look at these guys. 3 to the x times 3 to the x. So one way you could look at that is simply, there's 2 ways I could look at it. I like to do is if I say, okay, I got the same base, and if you have the same base and you're multiplying 2 things together, you add the exponents. Right? That's one of the rules. If this is the same base, you multiply and add the exponents. So you could immediately look at it as x plus x, which is 2x. You could also look at it a different way. You could be like, 3 to the x times 3 to the x, that's really like 3 to the x squared. You see that? Because it's 3 to the x times 3 to the x. It's like a times a. A times a, which is a squared. So it's 3 to the x squared, which that's equivalent. Because then that 2, because remember what happens, there's another power rule. If you have something raised to an exponent, you distribute that inside the parentheses. So that would become 3 to the 2x. And on one hand, you could say, well, I'm done, right? There's my answer. But if you look in the back, they don't leave it as 3 to the 2x. They bring it to 9 to the x, which is equivalent. So I don't want to get split hairs too much. I think the general rule, from looking at their example they gave, in example 12, because in example 12 they got it to this 2 to the 2x, but then they simplified it, and I'm going to put quotes around that, because in their mind this is more simple. And I'm guessing the rule they're using is, and I don't want to say this is a rule, the guide they're using is to say, well, if I can simplify the exponents, then that's going to be simpler. You know, I mean, do I agree with that 100%? I don't know. I have to think about that. I guess there's less things written 2 to the 2x versus 4 to the x. So where does that come from? Are we sure that even works? So what you would do to think of that is you'd be like, oh, it's kind of like a two-step process. Let's do it with 2 to the 2x first, and then we'll do it with our other problem. So 2 to the 2x is really the same as 2 squared to the x. Do you see that? That you could put that first, and then 2 squared we know is actually 4 to the x. So it's kind of weird. It's like with our problem, we're going to flip it. We're going to start with, like if we started here with 3 to the x squared, then I brought the 2 inside, and then I would bring it back out, and I'd bring the x out, and I'd be like, oh, well, that's 3 squared to the x. So I'm just playing games with it, bringing the 2 in, and then bringing the x out, and then 3 squared x, of course, that's 9. 3 squared is going to be 9, and the x still is up there. So you just have to be careful. Also, if you looked at it from this point of view, you could see it right here as 3 squared x. You're like playing these little games, like putting parentheses in. Of course, my workspace is getting so messy. I hope you followed that all, and I hope that makes more sense. So the first step is with the FOIL, then you carefully start to combine terms together, and hey, trust me, you may pull your hair out a little bit, but hopefully you did all those cons. I think about all you guys did your cons to remind you about all the power rules, and this is really going to test you with it. So I'm going to post this up. If you need more help, let me know. I can do another one.